and welcome to another GCSE Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on representing images. Bitmap images are made up of rows of pixels. Pixel is short for picture element and is the smallest observable part of a picture, essentially a single dot in a picture. Each pixel has its own color, and each color is represented by a unique binary number. The size of an image is found by multiplying the width in pixels by the height in pixels. The more pixels an image is made up of, the greater the detail it contains, but also the greater the file size, as we have to record the color of each of those extra pixels. Resolution is linked to, but not the same as, image size. It is the number of pixels in a given area. Displayed or printed at the same size, an image with more pixels will have more detail, as you can see in this example below, of the same icon printed at the same size, but with different numbers of pixels used to represent it each time. You can see that the one that is 512 by 512 pixels has significantly more detail than the one at the other end of the spectrum that is 16 pixels by 16 pixels. So in summary, the higher the resolution, the better the detail, but also the higher the file size. Color depth is the number of bits used to store the color of a pixel. You can represent 2 to the power of n different colors, where n is the color depth. So, if we use just 1 bit for representing color, we can only have 2 colors in our image. With 2 bits we can have 4, and so on. A standard JPEG image is made up of 24-bit color, meaning that there are 16,777,215 possible colors. If we look at this simple bitmap image of a watermelon, we can see that it has 6 colors: white, black, 2 shades of red, and 2 shades of green. If we were to use 2 bits, we would not have enough possible combinations to be able to represent all our colors. So we would need to use at least 3 bits to be able to represent this image. 3 bits would leave us with 2 possible combinations that are not currently linked to a color themselves. Images and other files also include what is known as metadata. This is data about the file itself, such as the author, date created, and file type. For images, it also includes data needed to reassemble the image, such as the height and width in pixels, the resolution, and the color depth. The basic formula to calculate the size of an image file is width in pixels times height in pixels times color depth. The most common mistake to make is to multiply by the number of pixels instead of the color depth needed for that many colors. So our watermelon that we see here is 15 by 15 by the color depth, which is 3, not the 6 different colors that are in it. This gives us 675 bits, or 84.375 bytes. That brings us to the end of this video on representing images. Join me again in the next video when I'll be looking at representing sound. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.